It was dragging. I was like, man, what is going on? All right. Let me just actually right here. Shut that down. Here. Done. Let me check one more time. Cool. Share my screen. Start the broadcast. There we go. Right here. Okay. We'll start here. All right. So welcome, gentlemen. Let's see. We are all right. So we're here. Welcome. We are in the home stretch, right? So a brief synopsis of the remaining schedule for the semester. We're going to meet today, right? We'll take some time. So what we've been doing, I think last week we reviewed exam 1. So today we'll take some time to review exam 2, the material pertinent to that. We're not going to meet on Wednesday. I think the school closes at noon on this upcoming Wednesday, but we're just, we're not going to meet. So after today, enjoy your holiday. So take that time to, maximize your time with your loved ones and things of that nature, because no moment is promised. I mean, so many people I know are just dropping like flies. I've had students, loved ones, parents, like, 1 minute you're either arguing with the person or, laughing and playing, and then you blink your eye and then they just like disappear. It's like, damn, was that person really there? Or did they was that a figment of my imagination? It feels surreal. So, you just want to do the best you can to, do as much good for the people that you care about as you can while you can. You know what I mean? So, yeah, we'll take some time to go through exam 2 today. We're off on Wednesday. And then next week, so the last day of class is November 30th, right? So we're going to meet on Monday and Wednesday. Next Wednesday is the last time that you're obligated, that I'm going to take attendance, right? So the 30th, which is next Wednesday, is the last day of class. That Thursday and Friday, which is December 1st and 2nd, is a reading period. So, you shouldn't be meeting in any of your classes during that time. I think I scheduled for your final exam to become available Sunday, December 4th at 11:11 a.m. It is due Friday, December 9th at 11:59 p.m. So during the week of finals, more than likely, I will be online during class time, but you're not obligated to be in attendance there. I'm not taking attendance. I'm not taking attendance on those days. I'm just going to be online. More than likely, I'll be gaming. But, I'm going to, obviously, I'll make myself available just to answer questions. And, if you need to, pop in or whatever, just so you can find me and reach me. So during the week of finals, again, more than likely, I will be online on that Monday and Wednesday. But you're not obligated to show up. Your obligation, as far as attendance, last time I'm going to take attendance is November 30th. And then from there, all you really need to do is just submit your items on Pearson. The goal is when you submit your final exam, you shouldn't have anything lingering. That should be the last thing that you submit. So in order for that to be the case, right now, you want to go ahead and get as many of your assignments on Pearson in order as possible. That was weird the way I said that, but I think it makes sense, right? So if you're going back to improve your overall score, again, this is across the board. This is for everybody, no matter what position you're in. You definitely want to prioritize your old exams as they count for 80% of your overall grade. And so that's where you're going to get the most bang for your bucks. And then the last thing that you want to prioritize is the homework. The homework is a whole bunch of work for little points. You're not going to see your grade move that much doing that homework. So I don't really want you stressing out about the homework and quizzes. But the main thing is you definitely want to get your exams in order as soon as possible. And then once the final becomes available, that should be it. You shouldn't have anything lingering. Again, the hard deadline is Friday, December 9th at 11:59 p.m. So everything is due to final. Anything that's on Pearson, everything locks out at that point. I can't push anything back past that date. As we have to calculate final grades and submit them. Okay. So, I do these announcements because it's usually the same question, or how do I improve my grade, or what am I looking like? It's the same for everybody. Just you get unlimited attempts, focus on your exams, get those in order, and then that's the bulk of it. That's the bulk of it. Okay. So, oh, let's see. Yeah, I can't think of anything else. Those are the pertinent items. Okay, guys. So what we're gonna do today, we're gonna take some time and basically, okay. So when I'm going through this, when I'm reviewing this exam for exam 2, my intent is to just draw out as many concepts as we can. So I'll use the questions as a launching board or launch pad to like expound on the concepts that we come across, right? So, and as always, if you have questions, feel free to unmute yourself to get my attention and we can talk about it. Okay. So this is exam 3 covering exam 2 covering chapter 3. Okay, so here we have for this exponential function, evaluate f of 2.7 and use a calculator if necessary. So for something like this, evaluating exponentials, okay. This is a calculator problem. I kind of do want to mention a few things. All right, yeah, let me do this stuff. So let me just mention a few things when it comes to exponential functions. So if we consider exponential functions, right? These are functions of the form f of x equals a to the power of x, where a is not equal to 1 and a is also strictly greater than 0. So the base has to be strictly greater than 0 and not equal to 1. And then the general shape of an exponential function, you have 3 key points that you kind of look out for. So you have like this point here is the point 0, 1. You also have the point that's about here, which is -1, 1 over a. And then you have a point here, which is 1, a. All right, these are 3 key points. And then the general graph of an exponential function, to the far left, you start out infinitesimally close to the x-axis, but there's always space. You pass through these 3 key points, and then it goes like this, all right? And then, so we have like a horizontal asymptote, all right? So this is like the main gist of exponentials. When you go off to the far left, you're infinitesimally close to the x-axis. As you go off to the far right, it grows exponentially and takes on this shape. Some other properties: the domain, the general domain of exponential is going to be all reals. So it's going to look something like this. Okay. The range goes from 0 to infinity. Infinity always gets a parentheses, and 0 in this context gets parentheses. This parentheses in this context means we get infinitesimally close to 0, to y equals 0, but we never actually reach it. As long as we don't manipulate the graph, it never touches the x-axis. So that's one main property. So then the inverse, if we wanted to consider the inverse, let's try to clean it up a little bit. The inverse, why am I not writing this? Inverse. The inverse of exponential functions, let's do it in this color. That's going to be the log function. I'm just going to abbreviate it as log. Log functions, right? So these functions are going to take on the form. There's a couple of them. We got f of x equal. Did we talk about logs? You know what? I don't even know. I'm not sure if that's you guys or not. I don't want to add things that you don't need. Let me check something. Let me check something really quickly. That's fine. Yeah. Okay. We did. I just needed to make sure. I didn't want to launch into it. Okay, so the general shape or the general form of the log function is going to be log base a of x, right? And then I think the properties hold there. Let me see. The base, can it be 0? Can it be 1? I think it cannot be 1. And I think these properties still hold where I want to say that a can't be equal to 1 and it has to be strictly greater than 0. Mm-hmm. And it's basically, and so whenever we're dealing with inverses, a lot of the properties are reciprocal. The graph rotates about the diagonal y equals x. So like if you were looking at the graph of the log function, right, you have something like this. Your 3 key points when y is -1. So you have like a point here. Let me see, x is going to be 1 over a comma -1. Everything is just reversed. Then you have this point here, which is 1 comma 0. And then you have a point here, which is a comma 1. All right. It's basically if you take the properties of the exponential, you flip everything, and the graph, you rotate about the diagonal y equals x. And you'll get something like this. It starts off here, passes through the 3 key points, and then goes off to the side like that. With log functions, you have a vertical asymptote, something like this, right? Okay, and then the domain of a log, everything is reversed. And I think this will be enough. So the domain of the log goes from 0 to infinity, and the range is all reals. So then once you have a clear sense of exponentials, you can just reverse flip a lot of the properties, and then, it kind of holds in that sense. Okay. Let me do something really quickly like this. That's probably not far enough. Let's start here. So I think that's a decent synopsis of exponentials and logs. There's more, but I'll kind of launch into more as it kind of pops up. I was just shrinking these down so that they fit in their respective spaces. Nope. Let's go. Come on. Okay, that's good about. And then this one, we'll get back to the original task. That's decent. Okay, so that's just a brief overview of exponentials and logs, right? There's more, but for now, that's good. Okay, let's go back to our question. Let's see, it's this one. So for this exponential function, we're asked to evaluate, right? So again, the thing that makes it exponential is because we have the variable in the exponent, and then the properties of the base. So then something like this, you would just use the calculator. So let me open up my trusty dusty rusty. I can right here. Okay. Let me see. Let me check on you guys in Zoom. Let me finish this one, then I'll check on you guys in Zoom. I usually do it at the 15-minute mark. So something like this, I prefer to do like if I hit y equals, then I'm gonna say 5 to the power of parentheses 1 minus x. I feel like I make less mistakes when I do it this way, right? I put my function in, typed it in proper using parentheses in the proper manner. And then I'm going to call on that function. If you need me to go through these details of how to do that, I can. And I'm just going to type in 2.7 and then hit enter. It says type an integer or decimal rounded to 3 decimal places. So 3 decimal places would be 0.064. After the 4 is an 8. The 8 tells me to round up. So it's 0.065. So then 0.065, no, let's try that again. 0.065, looking good, okay. So again, my intent or goal is to use the questions as a launch pad to kind of expound on concepts and try to share as much information as I can while answering the question. Let me check on you guys in Zoom right here. Cool. All right. Let's get the student. Okay. All right. So match the graph with one of the following functions. So then this question launches into transformations. Transformations. There are a total of 8 transformations from College Algebra 1. I don't know if you want me to write those out or not. You know, I'll just mention them. If you want me to write them, if somebody requests it, then I'll write it out. But this is from College Algebra 1. So transformations, I think there are total, it's either 8 or 10, but I think it's 8. So the first category is like, outside manipulations, like manipulations that are outside your basic function. Those cause vertical changes. Manipulations inside your basic function cause horizontal changes and are typically the reverse of our intuition. Yeah, it's kind of a lot. So I'm going to leave it at that for now. There's more. I'm gonna just leave it there for now. So match the graph to one of the following functions. So it's not just a regular exponential growth. We have exponential decay, right? So let me see. More than likely, we have a negative exponent. I'm thinking like B. B is looking promising. All right. So if B is correct, when X is 0, Y should be 2. Okay. When X is 1. Let me see. When X is 1, Y is 1. So it can't be B. Let me think about it. It's a half. Yeah, because that's 2, that's 1. So let me think. We didn't move it up or down. Do we cause a vertical stretch? Let's see. No. When X is -1, we need to be at 4. It needs to be at 2 somewhere. Okay. When X is 0, it's not that one. Okay. Another way that we could go about it, we could start with the general function and then use transformations to just generate it, right? It does look like the base is 2. It looks like, okay, the base function might be y equals 2 to the power of x, but it looks like we flipped it horizontally, right? If we flip it horizontally, then that's when you multiply the inside by a negative. So instead of being 2 to the power of x, it would become 2 to the negative x. Let me see, if I put a 1 there, that's a half. So there's another manipulation we need to try to account for. Let me see. When x is -1, when x is 0, okay, I found it. So when x is 0, we should be at 2, right? Is that it? I think I see it. When x is 0, that's not it. Let's try, what about that one? Yeah, that one looks better, right? Okay. Yeah, it looks like we may have moved it side to side. Okay, I'm leaning towards G, right? Let's test those 3 key points that we talked about. So when x is 0, we should be at 2, and we are. When x is -1, right? 1 plus 1 is 2. 2 squared is 4. That one checks out. And then when x is 1, oh shoot, that doesn't work either, right? Because 2 to the 0 is 1. Yeah, no, I think we're good, right? Because when x is 1, we should be at 1. So the one that looks like it's working is G, all right? Let's test it one more time. When x is -1, 2 squared is 4. That checks out. When x is 0, we get 2. That checks out. And then when x is 1, 2 to the 0 is 1, right? So we're going to go with G. So, but the way I did that one, I just used, if it's correct, it should be correct. We won't know it's correct until I submit the exam. But I just kind of evaluated those 3 key points and, just kind of going back and forth between transformations and like a guess and check. Okay, write an equation of this form from the given graph, then compute f of 2. So they gave us 2 ordered pairs. Okay, so let's get a copy of this. I'm gonna go here, here. Okay. I'm gonna say copy and delete. Here. And let's paste. Allow the paste. All right. Write an equation of this form. Okay. So we're gonna start. Let me see. So we have 2 ordered pairs. All right. So we're gonna plug in those x and y's. So for instance, when x is -1, we're gonna have a to the -1 plus b equals, and the corresponding y is 1. And then when x is -2, the corresponding y is 13. Okay. So we're going to create a model that fits this data. Okay. Let's see. To me, it looks like it's easiest to possibly, let's go ahead and solve for b. Or I guess we can just, we can multiply equation. I'm actually going to switch the order like this. I'm going to just move this guy up here. And then I'm going to say equation 1 minus equation 2. So I'm going to distribute a negative. I'm going to say a negative here. I'm basically multiplying row 2 by a negative. And then I'm going to add these 2 equations together. The goal is basically I'm going to get these 2 guys to cancel out, right, when I do this. So then we're going to have a to the -2 minus a to the -1 equals 12, right? So these are all fractions. I think I'm leaning towards clearing out the fractions by multiplying by the LCD of all the fractions, or the least common multiple. So in this case, I'm going to multiply each term by a squared. Okay. So I'm going to say this guy times a squared times a squared and times a squared. All right, this will clear out my fractions. Okay. So then the first term becomes 1. That's going to become minus a equals 12a squared. I'm going to move everything to the right and set it to 0. So then I get 12a squared plus a minus 1 equals 0, right? All I did, I moved everything to the right, and then I just reversed it, right? If the left equals the right, then the right equals left. I just wanted my 0 on the right-hand side, okay? So then we want to factor this guy. We're looking for two numbers that multiply to give us -12, right? You got to say the a times the c because the leading coefficient is not a 1. So you got to say the a times the c. Two numbers that multiply give me -12 and add to give me 1. Now 12 is what? 4 times 3. So that's 2 times 2 times 3. And I'm going to go through all the combinations until I get to the line that adds up. It's really 4 and 3, right? We don't even have to do that. So it's just going to be, should be a +4 times a -3. Okay. So what we're going to do, we're going to rewrite this a. Well, actually from here, I personally like to use the box method. So the box method is something like this, right? Where this is just a factoring technique. In the upper left-hand corner, I put my leading coefficient, my leading term, 12a squared. The bottom right is the constant term, which is this guy. And then in the off diagonal, I'm rewriting this a using this 4 and this -3. Okay. So I'm going to say there's a +4a here and a -3a here. All right. So then when I go to factor this guy, okay, first I'm going to ask myself, okay, what can I factor out of the 2 on top? It looks like they both have 4a. So we can factor out a 4a from those 2. What do the 2 on the bottom have in common? They both have -1. What do the 2 on the left have in common? It looks like you can factor out a 3a. And the GCF here, what do these two have in common is just 1. Okay. I think I'm gonna kind of continue over here. So then our claim is that it factors into 4a minus 1 times 3a plus 1. Okay, equals 0. Okay, and you can check, right? 4 times 3, you get your 12a squared. 4a minus 3a is 1a, and then -1 times 1 is -1. Okay, so then from here, you said each one is 0 unsolved. You get a equals 1/4 and a -1/3. Okay. Okay, so then for exponentials, we can't have a negative base, so we have to scrap this guy. So then we're going to keep a as 1/4. Then we're going to use that to solve for b. I'm going to plug it into equation 2. It just looks easier to work with. So then essentially what we have is 1/4 to the power of -1 plus b equals 1. Negative exponent flips your fraction. So you get 4 plus b equals 1. So then b equals a -3. Okay. Let me highlight these guys so I can see them better. So then our claim is that the function is ax. Okay. So then our claim is that our f of x, our a we got was 1/4 to the power of x minus 3. Okay. So then, since this is a test, we basically want to confirm that this model works for the given points, right? So we just want to test and make sure they work. Okay. So I think what I'm gonna do, I'm gonna use my calculator if I can get this thing to behave. Come on. That's the main things that I think. Right here. Nope. This one. No. What are you doing? Thank you. This one. Just stop checking you guys in Zoom. Okay. So what I'm gonna do, I'm gonna go to my y equals. I'm gonna put the model that we just created, 1/4 to the power of x minus 3. Okay. I want to call on that function that I just put in. So then when x is -2, we should get 13. And when x is -1, we should get 1. That's about the best we can do. 1/4 to the power of x minus 3. 1/4 to the power of x. This one, go full screen. Oh. 1/4 to the power of x minus 3. Okay. And then when x is 2, okay, so we can use our trusty dusty Rusty, this guy. So then when x is 2, type an integer or a simplified fraction. Let's hit math as a fraction. Yeah. We got -47/16. -47/16. -40, nope. 7/16. Okay. Let's take about 5 more minutes. Let me check on you guys in Zoom. Okay, you guys are looking good. Stop. Let's take 5 more minutes. See what we can do in 5 minutes. Starting with the graph of this, use transformations to sketch the graph, okay? So I'm gonna click to enlarge the graph. We can see the function to the left there. We're working with the exponential function, and I'm just clicking anywhere on the graph, right? So I'm gonna use this tool here to capture my transformations. Now, when you're doing multiple transformations in one function, the recommendation is to work your way from the inside to the out. So you want to start with the innermost transformation and then work your way out. The innermost transformation that we have here, we multiplied the inside by a -1. So that's going to cause it to flip horizontally. So we need it to reflect over the y-axis, okay? Let's see. Then we multiplied the outside of our basic function by a negative. So that's going to cause it to flip vertically. So we're going to flip over the x-axis. Okay. And then we added 5 outside the base function. So that's going to cause it to move up by 5 units. So we're just going to change this to 5. And that's it. I'm going to hit save. We got time. Let's keep going. Let's do another one. Oh, no. The horizontal asymptote is y equals 5 because we moved it up by 5. Okay. Let's see this one. It says in 2001, the median price of a house in the city was this. Assuming a rate of increase of 2% per year, what can we expect the price? That's using something I'd have to look at that one up. Let me see. Okay, what isn't it? Assuming a rate increase of 2% per year, what can we expect the price of such house to be in 2015? So this sounds okay. I'm going to give it a go. Do not round. I think this is just exponential growth, right? I'm going to model it to the exponential growth function. Let's give that a go. I think that'll work. I'm a little bit, a little bit iffy on this one, but I think it's exponential growth. I'm gonna go like this. I'm gonna copy and delete. This will probably be the last one. No, not Zoom. Because we're pretty much out of time. Okay. So only thing I'm not sure if it's like a special, sometimes these are like special formulas, but I think it's just a regular growth model. So exponential growth, let me see. You can say like A naught e to the kt, right? So they're giving us data. So this is like exponential growth. Your A naught is like your starting amount. Your K is your rate. Your time is in years. So let's see, in 2001, the median price was this. Assuming, so we know that the K is 2% per year, okay? 2015. I guess we could let that be 0. So we'll let 2001 be when t equals 0. We'll let that be our 0. Okay. So then when the time is 0, we're at 150. Okay. Okay. So if 2001 is when t is 0, then this is 14 years later. So we want to find the value when it's been 14 years later, right? So we're starting with 150, 1, 2, 3, e to the, let's see, the rate is 2%. As a decimal, that's going to be 0.02. And it's been 14 years, right? So then we just put that in the calculator. This is going to be the last one because we're essentially out of time. Let's see. So I'm just going to put 14 years later. Guess so. Let's give it a go and see what happens. I'm just thinking like the number seems like it's going to be large. We're going to say E right here, second, e to the power of 0.02 times 14. Let's see. Okay, that's not too bad. So 198,000. Okay. So then we go back here. This one. The 9 is a 4. The 4 tells us to stay at 9. Do not round it to the final answer. Okay, so we're gonna go with this. If we can get this to work. Come on. Okay, so 198, 469. Okay. All right, so we're gonna go ahead, let's hit next, and we're gonna submit this. Oh, I totally wanna do that, but we're out of time. Let me submit the test. Looks like we've done what, like 4 questions? Yeah, I think we got it, right? I don't think we worked on number 5. Oh, we got it wrong, okay. 197. Okay. Okay, so we just used the wrong formula. Median price increased by 2%. Compound interest formula, okay. That's fine. Yeah, that was the only thing I wasn't sure about. So, but yeah, we used continuous compound interest. We should have just used the regular compound interest formula. Okay, well, that's fine. You can't win them all. Okay, so we definitely got that wrong. That's why I was hesitant. I was like, I wasn't sure, but that's okay. Okay, guys. So I can strike through this. Let me at least, so this formula is wrong. Let me at least put the correct formula. So let me strike through this. It was this guy that was wrong. We should have done this guy. P times 1 plus R over N to the power of NT. And then everything else kind of holds, right? Okay. So I'll just highlight it like this. Are there any questions? So while you think about questions, let me go ahead and make a copy of this available so you guys can have a copy of what you saw me writing fall. This one, notes, updated daily. Yeah, this one right here, it's in the box, okay. So when this bar finishes loading, you'll get a copy of everything that you saw me writing. And if there aren't any burning questions, we're gonna end the session here. Happy holidays, everyone. And we will reconnect a week from today. And otherwise, take care. Peace.